Okay. Good afternoon, everyone. Thanks a lot for joining the second episode of VizConnect. So, my name is Sagar Kapoor, and I'm a customer success manager for Tableau. So, really excited about VizConnect. So, in the first episode, we had 150 people who registered, but this time we have 270 people who have registered for this session. Thanks a lot, everyone, for going ahead and taking this effort to register yourself. So VizConnect, just to talk 2 minutes of the VizConnect. So VizConnect is a bi-monthly call in which what we are doing, we are basically connecting people with the art of data visualization and storytelling. So we had a first episode in the last month, and I think it was a very good session. Got a good feedback from everyone. Thanks a lot for that. So in today's session, we have two speakers. We have Mrinal Daryani from Tableau, who will be talking about Spatial Showcase, and we have Kizley Benedict, who will be talking about from Johnson and Johnson. Sorry about that, designing effective tables. So just some housekeeping items before we start the session. First, keep yourself on mute. If you have any questions, go ahead and use the chat window to basically ask them. So we have a good time at the end of both the sessions, a proper Q&A in which you can ask the experts everything you want to know about data visualization and storytelling. So without further ado, Mrinal, over to you. So let me just introduce Mrinal, and I think the important thing about his fun fact which he has shared with us. So just to talk about Mrinal, so Mrinal is a principal product consultant with Tableau. So Mrinal has helped 100 clients across APAC to adopt analytics at scale at large organizations. So if he is not playing with data, he encouraged everyone else to play with it. So the most important thing, the fun fact about Mrinal, and I think I will also go ahead and test this with my wife also. So Mrinal, in order to settle a debate with his girlfriend about whether he replies on time on her messages, he exposed his WhatsApp chats and analyzed into in Tableau. And the result was that he won the debate. So Mrinal, over to you. Thank you.
Hey, Sagar, can you hear me?
You loud and clear. You are on.
Okay,
Yep.
great. Um, Thanks, and sorry, one more thing, Sagar. You can see my screen, right?
We can see your screen. Yes.
Okay, great. Thank you.
Perfect.
Thanks a lot for that introduction, Sagar. And I want to say hi to everyone, but since we're such a varied group, I didn't know what was the best thing to say, ladies and gentlemen, or anything like that. But I saw that Ravi had actually posted a good term in the chat. He said, "Hey, data fam," and I want to say the same thing. Hey, data fam. What I want to cover today is something called Spatial Showcase. Basically, what I just want to answer the question is just how far can you take Tableau's mapping capabilities, right? I think we all know that Tableau can actually, you can build a map very easily in Tableau. But the thing is, like, just what can you do with it from basic to intermediate to advanced? That's what I want to cover today. What are the various use cases that you could do with Tableau's geospatial capabilities? I'm part of the Geospatial Champions team in Tableau, so I thought this would be a good time for me to share with you guys what we've been putting together. So, a summary of what I'm going to present is actually on your screen right now. What you'll notice is that it's not just building different types of maps. There's many different things that you can do. And so, let's actually go into every single example. The first thing, of course, is that if you have data that's geographic in nature, of course you can visualize it, right? And the thing is, I'm sure we've all seen what the basic maps look like, but the fantastic thing about these basic maps is that you can visualize them with just a double click. The reason for that is because Tableau can automatically generate the latitude and longitude for many different levels of data as long as they're supported. So, for example, I know that a number of us are actually from India here. These are the levels. If you have this data in your data set, for example, airport names or city names or even county names for India, just having those names in your data set, Tableau will automatically be able to get the latitude and longitude for them and visualize them. And the kind of maps that you can get can be more detailed than you would think, right? Not just at the very countrywide, but if you look at the examples that I have here, this example here on the left-hand side includes not just all my data points, which in this case, these are all trees in Melbourne. So every circle is one tree in Melbourne. Um, but what you can also notice is that I actually can see things like this garden, the train stations in Melbourne, the universities, the names of the roads. All of these are actually levels of detail that are available in the default map layer. Uh, we also we also have the option to give you satellite view, so you can kind of see things like elevation and sorry, not elevation, terrain, um, and a few other levels of detail. Now, sometimes you don't just want to visualize individual points. You actually want to visualize density. So you have a lot of data in a single place, and here are some ways that you could do it, right? Um, in this case, we're looking at data which is 1 million taxi rides. So this is actually 1 million data points right now on the screen, what you're looking at here in New York City, right? And you can imagine with taxi rides, there's lots of similar pickup locations and drop off locations. So this is actually a visualization of 1 million points overlaid on top of each other to show you a heat map, right? And another way, of course, you could do it is by creating sort of like these hex bins that will give you selectable bins of your data, right, that you could use to analyze. Now, of course, just visualizing it, there's many different other ways that you could do that. You could visualize it as a flow map, as a network, contours, cartograms, and etc. And there's no real limit to the kind of fanciful visualizations that you can make. So that's just seeing your data. Now, what else can you do beyond that? Well, what you can do is not just see your data, but also have external services or custom data as part of your visualization. So what you're looking at right now is two examples, one using something called a WMS server and the other one using a layer from Mapbox. Both of these are external services, but we're basically replacing Tableau's default map layer to give you, in this case, the weather. So this is in WMS server, which has the weather. And then here we have a um, pretty cool pirate map, right? I mean, this is just for fun, but it's just an example to show you that you could have your own map layers, right? Now, this next point is available only in the US for now. I think because that's where we have the ability to get this data. So this is a US only feature. But in the US, if you're analyzing that data, this layer includes the, data that might be useful. Okay, so
So, sorry,
yeah.
sorry, Mrinal, just a second.
Sure.
Yeah, go ahead,
Okay.
please. Sorry.
Yeah, no worries. So this is map data, right? Here we can actually see the per capita income in the US as well, right? So this is just, it's just good to know when you can kind of analyze your data and you can, for example, zoom into California to this section over here and very quickly see where we're selling the most items. Is that corresponding with where people can actually afford it, right? The next section, of course, is, well, not just visualize your data, but make it interact with the rest of your data. So here's an example where we're looking at airport routes or the number of basically routes or number of flights for a particular airline, right? So for example, I've currently selected my destination to be the Thailand Central Airport, Suvarnabhumi, and I can actually very quickly see all the airlines that are that have a route into this particular location, right? Um, Let me see if we have. Do we have Air India here? Okay, great. Let's actually see. Okay, so Air India does actually have flights that fly into Suvarnabhumi from Mumbai, Delhi, and if I'm not mistaken, that's Singapore. So, in addition to building interactive dashboards like that, where your map interacts with, for example, bar charts, you could also have those other charts directly within your visualization. So right now, this is the same Melbourne trees data set, right? So I'm looking at the trees of every single tree in Melbourne. And when I've hovered over this Rosacea tree, right, it is actually showing me the history of that entire group, all those Rosacea trees, and the history of it being planted. So this visualization is popping up when I hover over a data point. And maybe let's look at another one. So here I can look at the history of all of these red trees. I'm not even gonna try to pronounce that. Sesel Pinicea, whatever. Um, so yeah. So same thing. I have the same data set, but this time instead of hovering over a tree and then seeing the history of similar trees, I want to hover over a tree and see that area. So what I've done is basically hover over this area. Oops, sorry. So yeah, so when I hover over this particular data point, it's as if I'm putting a magnifying glass over that map because I can actually see what else is happening in that, let's say, 100-meter box, right, around that tree. Let's try another one. Zoom in over here. Yeah, I can see that this area actually has 36 trees from 4 different families. So fairly diverse tree area. Great. So that is, so now let's talk about, in addition to just sort of like playing with your data on dashboards, let's talk a little bit more about integrating your spatial data. So when you have spatial data, you don't only just want to play with just that data, right? You of course want it to be, you of course want to play with your other non-spatial data in your data set. So let's see how you could do that. So one very common way to do that is something using something called spatial files. So a spatial file is a file type that is optimized for storing spatial data, right? Because as you guys can imagine, the Excel CSV world, it's great for the kind of spreadsheet data that we need to use, but if you're working with points and polygons and very complex types of data, you would want to use a file type that's optimized for it, and that is a spatial file, right? And spatial files are actually fairly more common than you might think. There's a lot of them available on the internet, especially usually provided by government websites. So here is an example where we're actually using a spatial file, which is the 18,000 sectors in the city of Sao Paulo in Brazil, right? And when I hover over any one of them, I can also integrate it with my non-spatial data, which is showing me the the average income for that particular sector code, right? So this is just an Excel file joined in with my spatial file. And the fantastic thing about having an optimized file like this is that watch what happens when I zoom in, right? I'm zooming in into, like I said, 18,000 sectors. And not just that, I'm also like getting all this rich level of detail, like every single boundary on this map, very smoothly rendered, right? And that's the beauty of working with spatial files. You can actually get this kind of
Mrinal, are you there?
fantastic.
I think,
Yep, I'm here. Issue with
yeah, yeah, we
my
lost
WebEx
you.
right now. Sorry. Okay. Let me just share my other screen. Okay. You can see my screen.
Yes, we can see your screen.
Okay, great.
Not the presentation one, like you want to. Yeah, now we can share it. Perfect.
Oh, I was just showing your house to everybody, Sagar.
Yeah.
But okay.
Yeah.
um, all right. So here we're back at the spatial file. So let's move on. Now, the thing about spatial files is that they don't just have to be sort of like levels of detail that you don't normally get in your data set, right? Here, what we're looking at is a custom designed spatial file. You can use open source tools like OpenGIS or QGIS to basically create your own spatial files. So in this case, we're looking at an example where we've actually moved Alaska and Hawaii, which are normally, on the west-hand side, and we've kind of moved them in like physical locations such that they're close to the rest of the United States, and we're creating these custom bins for the U.S. And these are completely custom created designs of data in the way that I want to see them, but you can do that with spatial files, right? Um, the next example is, if you have a spatial file, you can also join it with another data set. So here's an example where what I have is the city of Toronto, right? And I have a spatial file that contains all of the roads and trails in Toronto. So you can see it's all of these lines that exist there. And the question that I have is, which hotel which are all of these orange circles, which hotel should I pick if I want to go for a nice run in Toronto while I'm staying there, right? And just kind of visualizing both of these data sets helps me identify that um, maybe this this particular, okay, let's say for example, this particular hotel gives me access to, say for example, within about a 3.30-mile radius, gives me access to about 24 trails. So this is probably a really good idea of where to stay. And yeah, you could basically do more fanciful joins as well. That one was basically just a join where I just want to see literally an overlap of my data sets, right? Or sorry, not an overlap, but all of my data together, both the roads and the hotels. In this scenario, what I'm looking at is a direct overlap or an intersect between my spatial file, which is all of my grids, and my sales data set. So what this actually tells me is where have I made sales and where am I not making sales. So I can very quickly see that these are all of the sections where I have less than, basically almost no sales whatsoever. So maybe this is a good place where I should open up a new store, right? And if we click on, for example, a particular section here, it will still do the normal things that Tableau allows you to do, like do a forecasted sales for this particular selected section. All right. And now let's talk about running some analysis on all of your spatial data. This one is actually my one of my favorite examples in this entire workbook. So we're actually looking at the city of Jakarta in Indonesia, and the idea here is that let's say I click on this point. I'm going to click on this point from now on. I have reselected my point to be that's the point where I care about. So this is like this is my source point. And what I can do is set up for anybody on the line who's not mute, please do that.
Mrinal, sorry to cut you, but we are able to hear an echo.
Okay. Better. Let me just try to reconnect my audio.
Hey, Mrinal.
Yeah.
Yeah, you're fine now. Go ahead. Go ahead.
Is it fine now?
Yeah, go ahead.
Yes, it's perfect.
Okay.
Thanks, Mrinal.
No problem. So yeah, so I've clicked on this area and I've set up a 2.5 kilometer radius. And within my radius, if this is my starting point, I could then see what's within my radius and what's outside my radius. And I can very quickly compare, do I have better seafood restaurants in the what's within my radius or, based on price, based on number of restaurants, or is it better if I go outside of my radius? And the reason why this is my favorite dashboard is basically it's called justifying why I'm lazy, right? So yeah, and the fantastic thing about this dashboard is I'm using a dynamic. I'm making all of these calculations on the fly based on what the user has selected, right? Whatever data point they've selected, which just feels very natural. in what you're trying to do. Now, when it comes to analyzing it, sometimes you want to create new groups from your data. And in this case, I think we're familiar about the fact that when you hover over something, you can do these selections of points. But what I've done is I've done a similar selection like this already, and I'm able to actually create custom groupings of my data like this, just based on doing these lasso selections, right? So I'm able to create new territories to very quickly compare. Here in this case, average observed rate of a particular disease. You will see it by individual zip codes, but this allows me to group it up to the group level, so 60, 62, 168, etc. And it's so interesting because this area over here doesn't look like a real problem, right? Like when you're looking at the data like this. But when you group it up, you realize that the average observed rate in this section is so high, right? So there's really some value in being able to analyze and group your data in a very flexible way. Now that's a visual grouping. Of course, you can create your own territories using calculations. Like in this case, my zip codes are 5 digits, right? Like like this. They're in 5 digits. If I just do a very Excel-like function that says, give me the left 3 digits so that I can basically just look at it at the area level, right? I can basically create groups like that. The last two sections, one section here is basically talking about the fact that spatial data doesn't have to exist in flat files, which is all of the examples I've shown you so far. It is entirely possible, and it's also frequently used, that people have spatial data directly stored in their databases, right? And this example over here is showing me all of the locations in Seattle for schools. But this is not connected to a flat file. It's actually connected to SQL Server database in a spatial table, right? So we support SQL Server, and we currently support Postgres, Pivotal as well. And this is a very basic example where I'm just reading the data and just visualizing it. But the benefit of having spatial data on a database is that you can also use your database's functions directly, right? And start querying using these spatial functions. So here, as an example, what you're looking at here is a particular a particular school, Thurgood Marshall School, and what the spatial function I'm using is intersect, meaning show me how many how many parks within a 500-meter radius exist within a 500-meter radius of this particular school, right? So I can also still customize that to make it like a 600-meter radius, and it'll execute that query in real time against my SQL Server database, which might take a bit of time because it's actually stored in the US, but actually run that function directly against my SQL Server database. And now it gives me a different answer for Thurgood Marshall, right? So now within a 600-meter radius, I actually have 9 parks. Another example is, of course, spatial functions. There are a lot that could be used. The one additional, more advanced feature that I want to show you is the fact that what we actually want to do is we can actually create buffers where, let's say I have my center point of a particular school or a particular park, and I can actually create a buffer boundary behind it. So I've created a 600-meter radius behind it. So here you can see that same, where did Thurgood go? Okay, I lost that school. But you can actually see that within that I can create a boundary like this to very quickly see all the other parks that are intersecting with it. And the last section here that I want to cover is about visualizing spatial data that you might not really think is spatial, right? It doesn't fit our traditional mold of maps or locations, but there are things that you could do with it. So one example is you could actually use a background image as a map. So this is, I'm not sure how many people here follow basketball, but the NBA Finals just concluded today, and this is a very apt, very apt visualization where it's actually showing the Golden State Warriors as a team and where they tend to shoot from the court, right? So for example, if I click on Steph Curry, which we all know is a solid 3-point shooter. You can kind of see where most of his successful shots have actually been taken from, and yeah, he shoots from all over the place. And another example of using a background image is actually a factory floor, right? And what you could do is really even use things like animations to basically see where do people move on the factory floor, right? As a way of trying to figure out how to optimize processes or optimize design of the floor, right? Or where to identify when incidents have happened. Of course, as long as of course you're collecting this type of data. And the final example is an example that's basically using an image like a map, but also using other functions as well, right? This is actually this map that you're seeing here, or this image, is actually the Tableau Singapore office. And if I choose someone, for example, let's say I'm playing as Angelo Weissman, right? Where is Angelo? Oh, okay, here. So this is here. Angelo is over here, somewhere close to the south area of the office. And let's say Angelo is 70 kg. And let's say Angelo wants to go to his friend that's sitting over here. So probably going to go a few steps north and going to go a few steps to the right and a few more steps north to visit his friend right here. Okay. In the number of steps that he's walked 13 steps. He has burned 0.26 calories and he's taken about 4.71 seconds in time, right? And is another interesting way of just being creative in the way that you use things like parameters, filters, and calculations in combination with your map to build something that I don't know if anybody wants to know how much time it would take for them to visit their friends, but yes. So I want to conclude by saying, hopefully, you guys found this useful. The whole idea here is to get you guys inspired about the fact that what like just how far can you actually take maps in Tableau or take the mapping capabilities in Tableau. Um, and yeah, happy to take questions later on. I'll hand it over to Sagar.
Perfect. Thanks a lot, Mrinal, and I think thanks for showing the capability which are possible in maps in Tableau. Perfect. So let's get to the second session. So we have Kizley with us who will be presenting today on the I think the favorite topic of everyone who in a customer we talk about the tables. So let me just give you a brief intro to Kizley. So Kizley is a Tableau ambassador working with Johnson and Johnson as an analyst. He loves find stories in the data and represent using dashboards. The fun fact about Kizley is that maybe once I will meet him, will ask him, so he can do mirror writing. So next time, Kizley, when we are meeting, we are doing trying that out. So Kizley, over to you. Go ahead.
Sure, Sagar, thank you.
We can see your screen. Go ahead, please.
Okay. So can you see the full screen?
Yes.
Okay, sorry, just give me a minute.
Perfect.
Is
Yeah.
it visible now?
Yeah. Go ahead, please.
So I'll be talking about designing effective tables. I'm guessing creating tables is no one's favorite kind of visualization here, and including myself, because sorry, I think someone's not on mute. Okay, so designing tables, I'm guessing, is no one's favorite visualization, including myself. But since we all working in the IT industry, in some point of time we have been required to create tables. So it's always a good idea to keep some design tips in mind while creating tables and showing some efficient visualizations. So strictly speaking, tables are not considered a form of data visualization, but if you're working in the IT industry, at some point in time, you would have to create tables and show data because that is what the users would want. So tables do have a number of advantages. They allow for comparisons across values, and they help the reader to look up the exact numbers. However, despite these advantages, tables are still considered boring. So through this presentation, let's look at some ways to make tables more fun and user-friendly. So when thinking of tables, you would probably be asked to create a table or generate a table or just simply make a table. But can you design a table? The word design is not usually associated with table, but sure, we can definitely do some kind of design on table. So let's look at some things to consider while designing a table. So your table need not be a data dump, and it can be used to convey meaningful and precise information as well. So here are some points to consider while you create a table: the amount of data, the table structure, the colors and fonts, and the formatting. So the last 3 points would be part of your design elements, and we'll look at each in a bit of detail in the coming slides. So before designing tables, we have to think about when to use tables and when it is appropriate to show the tabular form of data and when it is not. So the first use case is when precise numbers are important. So when the user would want to look at exact values like highest profit, your lowest sales, or your best price. In these cases, the user knows exactly what he wants and would just like to look at the exact numbers. The second case is when the user is already familiar with the data. So especially in case of finance, while creating profit and loss tables or income statements or balance sheets, the user already is familiar with the structure of the data and would just like to look at what kind of values is associated with which line item. So an example is profit and loss. So the reader would probably know we have sales, costs, operating expenses, but he would just want to look at the exact values which are associated with each. So a table enables this lookup very quickly. The next example is when data has to be compared across dimensions. So in this table, we can look at monthly sales by region. So I can look at each month and compare the sales across a particular region, that is from top to bottom, or compare data across months. So I can look at region East and compare my values across the month. So a table enables this comparison across multiple dimensions. And while showing ranks, so this chart here shows the top 4 ODI teams as of now. So you can see New Zealand is ranked 1, Australia 2nd, England 3rd, and India 4th. But does this mean New Zealand is twice as better as Australia? Definitely not. So it's a bit meaningless to show ranks in terms of visualizations here. So the appropriate form of display would be to show it as numbers in the form of a table. Another important aspect is the table structure. So before designing a table, you should give a lot of thought to how would you like to structure your data and what columns would you like to include in your table. So the most important thing is to include only relevant data. So you'll probably be getting a lot of huge amounts of data, and you might be tempted to include a lot of it to show everything, but it's most often not a good idea because the user would want to see something very specific and only information which is relevant to him. So you'd want to cut down on your columns, show less number of columns to make your tables more readable. So another thing related to the data structure is your table should have more rows than columns. So if your table is designed wider, as in it has more columns than rows, it's always a good idea to swap them to show it in a longer format. Because the human eye is trained to analyze data from top to bottom, as it's more easy than analyzing data from left to right. So it's always a good idea to have your data structured in a long format. So the next thing is to identify your most important columns here. So this table shows the top 10 run scorers in test matches. So since it's about runs, the most important column would definitely be the runs. So we have included it at the very left. So the order to be followed here is left to right, your most important column to the left, because that's where your user would be looking at first. It wouldn't make sense if my runs was in between hundreds and fifties. So in this case, you have only 4 columns, but this comes in very handy if you have more than 10, 12 columns where the user has to look at very specific information. So it's always important to sort by the most important column first. So here you can see as we have runs in the first column, now the next task is to sort it. I can see my top run scorer now is Sachin. Now making columns narrow, it just doesn't mean in size, but also in the amount of text you show. So in this example, I have a table with 3 columns. The first one is the party name, Democrat or Republican. Second is the status of loan, which was approved or not, and is the amount. You can see a lot of text is repeated across. Not
Uh, Hello, if you are speaking, we are unable to hear you.
Kizley, I think we are unable to hear you. You're there? Hello.
Yeah, I believe some network issues.
can you hear me now?
We can hear you now. Go ahead.
Okay, sorry, I was on mute somehow.
Can you share your screen also? We are not.
Okay.
Perfect. Yep. Just open that PPT. Yeah. Sorry about that. Go ahead, please.
Do you want me to go back or is this fine?
Yeah, we couldn't hear about what you're talking about narrow columns.
Okay, I'll start with this again.
Perfect. Yeah.
So making columns narrow doesn't just mean making it narrow in terms of width or size, but using some removing some irrelevant information as well. So the table on the left you can see has 3 columns: the party name, the status of the donation which was approved or not, and the amount. So you can see the word Democrat is repeated twice. Status approved is repeated across the rows, and my amount values are not rounded off, and I have currency values displayed in every row. So there's a lot of extra information which can be removed, and I can use the information which is repeated in the headers itself. The more efficient design for this would be something like this. So I have my party name down to a single letter and color coded by the party colors. So people who are familiar with the Democrat and Republican Party would easily be able to identify with that. My status approved is now a binary column with just yes or no. So I have used shapes for that, and it's cleaner and more easier to read now. The currency is now rounded off to millions, and the USD value is brought to the headers. So I have gotten rid of all my repetitive information, and the table looks sleeker, much more attractive, and the values are easier to compare. So next thing I want to talk about is colors. So colors can really make or break your visualization. If we're using colors which are too bright, it could be difficult to look at the values and to compare values across. If you're using colors which are too dull, it might not help to improve your table readability as well. So this is again a table for the top 10 run scorers, but I have included a column for average as well because the top run scorer might not necessarily have the highest average. So I would want to compare that as well. So my top run scorer is highlighted with one color, and I can see in the average column, I can straight away look at my highest average, which is Kumar Sangakara. So you can always use colors to lead the reader to most important information or where you want him to look at. I could always show the lowest runs and the lowest averages as well. So in that case, choice of colors becomes very important. So you can look at two columns here. The first just shows the text which is colored. The column on the right shows the text which is background colored. And if you look closely, the text is colored darker. The background is colored a bit lighter. So it's always good idea to have your text with brighter colors, but while shading the cell background, use a slightly lighter shade. And while banding your rows and columns, it's again a good idea to use very light colors. So you can use gray or one of the pastel colors as shown. So this enables the user to look at the numbers as well as and also have a look at which columns are highlighted or rows in this case. Now let's talk about fonts. So just take 10 seconds to look at which font here is easier to read and compare. So I think most of you would have chosen Arial. The other two fonts might look good, might look funky and would attract the user's attention, but in terms of comparison, it's really hard to, for me at least, to read the first column and the third column. The numbers are too thick and it's a bit too stylish to look up exact numbers. Arial, on the other hand, is quite simple. I can scan numbers from top to bottom and look at which numbers are higher and which numbers are low. So always choose fonts which make comparisons easier. Formatting. So some points to be kept in mind while formatting a table. Your row header should be left aligned, numbers right aligned. So this is especially true for financial data where this kind of formatting is quite strictly adhered to. And when you're using row or column dividers, use a very light shading. If the user is comparing values across columns, it's generally not a good idea to have column dividers because that inhibits the comparison. In the same way, if your user is comparing values across rows, it's generally not good to have a thick row divider because that would again interfere with the readability. And use row and column banding where applicable. So if I have a large number of rows, let's say more than 15 or 20, it's always a good idea to band my rows. That way the user would not is less likely to skip any of the rows because of the banding. On the other hand, if I have like 3 or 4 rows, it's probably not a good idea to use banding because that could be confusing. So here's an example of a well-designed table which was published in the New York Times. It shows the murder rates in some of the cities of the US. So if you look at this, it's using most of the formatting and design principles we discussed. The headers are left aligned, the numbers are right aligned. It's sorted by the most important value, which is percentage change, which is in bold, so the user can immediately look at it. And the numbers are very simple, the font is simple, and it's very readable and easy to compare across. Another thing, another extra element added to this is the bar charts. So this enables me to look at the exact values, and using the bars, I can also compare the magnitude of each. So this brings us to the next section, which is visualizations. So visualizations would add another layer of information, and if one can include it, we shouldn't hesitate to have some kind of visualization in addition to the numbers which we're already showing in the table. So this is a snapshot from a viz I created for Bangalore's restaurants. Each column here is a specific type of restaurant. So we have buffets, cafes, pubs, etc. It's sorted on the basis of rating, which is the Zomato rating. But you can see there's a light bar chart in the background, which also shows the cost per restaurant. So it adds another dimension to my table. So it's not just numbers. I can also look at the bar charts, and it's just a good way to break the monotony of just looking at numbers. So here's another example by Zen Master Andy Kriebel. This looks at 5-year cancer survival rates in America. So you can see, in addition to the exact values for start percentage, which is the percentage rate at the start of the period, the latest period, and the change, there is a spark line as well, which gives the overall picture. So I can also look at the trends across time while looking at the exact values for a particular period as well. So it gives me both the overview and the data in a particular point of time. So this next table was published in a website called 538, which shows the top 10 teams in the English Premier League. So this data is based on a predictive score which they created, so which would be the SPI. And if you compare it with the points, you can see they were pretty spot on with their comparisons. So the things to notice here is my header is bold and a team logo is used here. So people who are familiar with the team logo can directly identify which team they would want to look at initially. And it also makes the table more attractive. And there is an additional kind of visualization here in terms of the color coding. So my offensive and defensive ratings are color coded, green being more offensive and red being more defensive. So it gives a very attractive look to the chart. And if you can see, there are very thin row dividers here. So if I would read across columns and across rows, my reading is not inhibited by the dark row dividers. So just to recap, display only relevant information, avoid the temptation to show everything in your table, because people would only want to look at specific data, and that is what which would make your table relevant and meaningful. Spend some time to plan your data structure, the way your table would be designed, what columns which we would use, and how would you place them. So once you get your structure correct, half the battle is won. Use simple fonts like the ones we showed. So while creating tables in Tableau, a good idea would be to use Tableau's inbuilt fonts like Tableau Book, Tableau Regular, or Arial, and avoid using bright colors where necessary. That would make it difficult to look up values. So I hope this was useful and you would take away some pointers of improving the design of your tables and how to make it less boring. Thank you.
Perfect. Thanks a lot, Kizley. I think now tables will be fun to work with. Looking forward to apply all the tips and tricks you have given to work on the tables. Perfect. So I think we have less time. Let's get started with the Q&A. So I will request everyone just to type in the chat your question, and the presenters are happy to go ahead and take your. So I think the first question which I will go ahead and ask from Kizley and Mrinal both, is it for those people who have just started with Tableau, right? So like they have just started using Tableau. What will be your, I think, few tips for them, how exactly they should start their journey? Maybe Kizley can start and then Mrinal can add to that.
Uh, so my Tableau journey, like most people, started when I discovered Makeover Monday. Uh, I just went to the website, downloaded some data, and got started with creating quizzes. I didn't start with any tutorials as such because that's how I like to learn. I like to create more than just looking up videos. So that might not be the best approach for everyone because there might be gaps in your learning. But if you're just looking for fun or just to pass time, it's a good way to start with visualizations. And always look at data which you're interested in. So if you're interested in movies, it's always a good idea to start with some movie data sets or TV show data sets or sports, whatever is your interest.
Yeah, and I guess the only thing that I completely agree with Kizley. The only thing that I would add to that is that, attending sessions like these, where you basically see best practices and you also see what's possible, is honestly also a great way to start because you have to be excited about something before wanting to learn it. Um, so yeah, once you get excited, then start pick your own data set of something you're passionate about because you're more likely to go into intermediate or advanced features without knowing it because you're trying to solve a question that's already existing in your head.
Perfect. And I think we have Divya also on the call. So Divya is a Tableau ambassador based out in Bangalore. So Divya, you want to add something?
Hi, Sagar.
I think
So,
just before that, so I think guys, you should give applause to Divya because everything is done by Divya just to go ahead and this concept of VizConnect connecting you all. So I think Divya deserves all the credit for this. She's brain behind this community. So I think thanks a lot, Divya. It's basically going ahead and starting it. Yeah,
uh,
go ahead.
yeah, thank you so much, Sagar. So basically, this connect, yeah, is this has been initiated by Sagar, and then it's finally happening here. So my suggestion here for the beginners would be, I started participating in the Makeover Monday project, which is being organized by the Tableau Zen Master Andy, and followed by with for social good. So basically, these community projects really help me to improve my data visualization skills.
Perfect. So I think I have one more question, and it's for Kizley. How to create an approved rejected marking table? Okay.
Okay, so if you mean the checks and the crosses, that can be done using shapes. So a shape is basically an image which you would place in the shape file in the Tableau repository. So once that is available in your repository, it would automatically show in the shapes mark, and then you can assign it based on the dimension.
Perfect. And I have one more question from Srinivas. So what he's asking, when the categories are less in number, but in the case of large categories, what will be your suggestion?
So if it is beyond a certain number of categories like 10 or 12, it's always a good idea to break down your tables. So if you have maybe 20 categories, break it down to two or three. So it's hard to say without looking at data, but there's always a way to like simplify it or break it down into smaller numbers.
Perfect. Yeah.
हाँ संध्या हाँ संध्या बोलिए ऐसे
Any other question, guys? Just
Yeah, I see a question from Nitin, which is there any plan to include constituency level dimension for India apart from district? Um, well, I mean, we're constantly trying to add more levels of data to every map, to the default maps that come out of the box. If it's not available right now, the best thing that you could do is just to like Google India constituency level shapefile. I think I've seen that before. I've seen postal code for sure. If you have that shapefile, just connect to it, and then it's fairly easy to just join that to your other datasets.
perfect. And I think one more question is there from Tapan Mrinal. To understand when there is no UX or wireframe design, it is very difficult to come up with meaningful visits. Any practical thoughts on that?
Um, well, okay, so I do have this has happened several times when I've worked with people who are with the business users who are not developing on Tableau, for example, right, gathering requirements. And what I do is I've taken some of the best practices of what I know here, but I don't spend too much time to build a very fanciful initial dashboard. The whole goal is to think about it in a very agile way, is to basically go to the customer saying, here's, I just quick and dirty put these five worksheets together into a dashboard. what is this what you want? Does this provide you, does this answer your questions? More often than not, they're going to say nope because I actually want this. This bottom right thing is actually the most important thing for me. And so the idea is to do that kind of back and forth feedback if there is no prior wireframe designed, right? And in fact, sometimes people design wireframes. But then it turns out that the end users, when it comes to actually time to reading and consuming dashboards, really want it to be rearranged. So this back and forth agile process has found this to be so much more useful.
Perfect. Thanks. So I think
Hey
Ravi.
Sagar, Tara here. I have a visualization which probably I want to show, and I feel that this is a don't do with the colors is what I feel. Maybe if I have the facility to showcase that, I just take a minutes of time and probably want a suggestion from people who are speaking today, if I am right or not.
Okay, yes, go ahead, please.
Okay. How do I share that? Somebody can help me out?
There is option to share your screen.
Okay, all right.
So Tara, just a second. I think we have less time right now. So I think let's go ahead with the question. Maybe what I can do, I can go ahead and set up some time and we can discuss about it. Okay?
Okay, fine. All right.
Yeah, no problem about it. Sorry about that. Yeah.
That's fine.
Okay. So I think we'll just take a last question. So let me see. So Mrinal, so
Hmm.
a person has a question about how do have you created interactive map which was showing route, basically a air route which you have shown over there, right? So
Yep.
any tips on that? Can you share something on that?
Yeah. So okay. So the interesting thing about those route maps is that in the past they actually used to be fairly difficult because you would actually have to restructure your data in order for it to work. The good thing is that the latest version that we have, there is a function called make line that makes this super easy. Um, that and plus, I noticed that there's a few people that have asked a similar question, saying, can we get the workbook? Yeah, Sagar will be uploading the content that both I and Kizley had shared into a folder. You guys can check it out and try to reverse engineer what we did there.
Perfect. Yeah. So yes, I think thanks a lot to Mrinal and Kizley for your time today, and thanks a lot everyone to attending that. I hope this is helpful. So I think to make it more better, so I have just pasted basically a feedback form for you guys. Just go ahead, give us your feedback so that we can make these sessions more interesting for you guys, right? So just take a couple of minutes, go ahead, complete that feedback. So, and the next session I will keep you guys posted, and we are all excited about it to go ahead and connect people with the art of data visualization and storytelling. So just a request from everyone, just go ahead and complete that feedback form. That is, we are a data company, so we need your feedback, how exactly you think our sessions are helpful to you guys. So Mrinal and Kizley, thanks a lot for your time today. It was a great session. I think we all learned a lot from that, and hopefully we all will apply it in our day-to-day work with respect to Tableau. Perfect. Thank you, everyone. Thank you. Have a great weekend. Bye-bye. Take care.